Yeah, something like that. And f of, let's say, 5 equals -3. Alright, to know this, you have to understand, is this even or odd degree? Is the leading coefficient positive or negative? Maybe then I'll be like that. So how are we going to do this? You need to know.
We have all the zeros.
What about the leading coefficient? What do you know?
It's -1.
It's going to be negative. The
Oh,
leading coefficient is
negative
going to be negative. Okay? So we need to remember that when we get down to...
Or negative A.
How about
That'll
negative
work.
A? Because we don't know what A's is yet. And this condition is going to make it where we have to find out what that coefficient is. All right. So what does this graph tell you about this function?
That's x times, or x plus 7 times x plus 4 times x,
All right.
x
Now
plus 2
why?
squared.
This is the key. Why is it x plus 2 squared?
Because it barely touches.
Yeah, because it sits on or hangs from there, right?
A shark
That
comes to
tells
eat
you
the
it's got to
birdie.
be even degree greater than 1. 3 over there. How are we going to deal with that? Cube. What tells you this one's got to be odd greater than 1? And it looks like it's going to sit there and it said, nope, change my mind, jump there, right? Okay. That tells you it's got to be odd. What about the 6?
X minus 6, x minus 8 cubed.
Okay. And so now, that's the general shape of that graph. That function will have the general shape of that graph if we plug in some positive number for A. Because we got a negative out front, it's going to make the leading coefficient negative, right? And that's what the graph tells us. The way the graph hits the x-axis, when it shoots through like that, tells us the factor associated with this root is the factor 1 time, like x plus 7. If it hangs from or sits on the x-axis like this, it tells us that's a factor an even number of times greater than 0. So that's why that one's square.
So if it sits on it like that, it's square?
Or if it hangs from it, like if it came up here and did like this. Okay? Or if it instead was flipped over and the graph came up like this and hung from it and came like this. Okay? If it just touches it, doesn't go through. Just touches it, doesn't go through. Shh. Guys. Yeah, if it comes down and acts like, hey, I'm going to sit there, and then, nope, change my mind, I'm going to go on through. That's when it has an odd number of factors associated with that root. Okay? So it's all on how it intersects that x-axis as to whether you have factor once, an even number of times, or an odd number of times greater. It's got to be negative. This is an odd degree with a negative leading coefficient because it starts up high and ends down. Okay? And that's how we know that A is going to have a negative in front of it. So now how do we satisfy this condition? F of 5 equals -3.
Solve for f of 5.
Okay.
Yeah.
So what's all it going to give me? -A times.
Let's see.
I'll let y'all put it in the calculator. It's going to be a huge number.
I bet. I got -1,143,072.
1 million.
Negative 1 million.
Well, I got 2 negatives in here, so it should be.
Oh. Okay. Wait, hold on a minute. Okay, never mind. Yeah.
Like that?
Yeah.
Just 72? Everybody get that?
Mm-hmm.
Alright, so what am I going to do to find A?
Divide -3 by that big number.
So I'm gonna get 3 divided by 1,143,072 equals A. That means my simplest polynomial.
Would that be -3?
Well, I divided negative on both sides because I'm just looking for this A right now.
Oh, okay.
He's doing a bunch of stuff in his head.
Well,
No,
could he have?
I'm not doing it here. I divided both sides to get A by itself, right?
By a negative
By
1
negative
million.
1,143,072.
I wonder if that number can divide by 3.
I don't know.
It can.
6, 9,
It's-
yes it will.
It will, but not by a very much smaller number.
If you reduce it, that's fine, or if you don't reduce it, that's fine, a fraction. My goal is to see that you know how to function behaves.